Okay, a question about experimental procedure. Let's just get this misery out of the way. All right. Draw the forces on a steel ball as it falls at terminal velocity. Okay. Oil, steel ball. Right. What are the forces that operate on a steel ball when it's falling at terminal velocity? Okay. Draw a little dot at the centre of gravity, centre of the ball. Okay. It's being pulled down by gravity, but don't write gravity. Okay. Write weight. Okay. Weight is the actual force. Gravity is the thing that results in there being a force. Okay. So use weight. Don't write gravity. Okay. Good. Right. What's operating upwards? Well, you've got a steel ball falling through oil, which is gloopy. Don't use the word gloopy either. So you're going to get some drag. You're going to get quite a lot of drag. So draw an arrow in the opposite direction from the center of gravity of the ball and try and get it to be the same length as the weight, because this is terminal velocity, and at terminal velocity the weight equals the drag. Okay, so the arrows should be the same size. Okay, call that drag. Okay, so don't be sloppy. Okay, be careful about the sizes of your arrows and be careful about the choice of words or terms. Don't write air resistance there or just resistance. It's not air anyway, it's oil resistance, but don't write that. Okay, it's weight and drag. Arrows the same size. Okay, and that will get you your 3 marks. Good. Okay, next question. Explain in terms of forces what is meant by terminal velocity. 3 marks. Okay, so we've touched on it a bit already, but here is the answer. I think is the best way of putting it. So a terminal velocity, first thing, okay, an object moves fast enough so the drag becomes equal to the weight. Okay, so drag becomes equal to the weight at terminal velocity. I'm writing it shorthand, otherwise this video would be 2 hours long, okay? But you have to write it out in a full sentence. Okay? Next. Therefore, the overall force is 0. So therefore, the overall, and I stress, use the word overall force, is 0. Okay? You have to use the word overall. It's very important to be careful with your language. Okay? It's not enough to say that the force on the ball is 0, because there are 2 forces acting on it. That's like, to say the force on the ball is 0, it's implying that there are no forces acting on it. Okay? You have to say the overall force is 0, because the drag has the same magnitude as the weight, but because they're in opposite directions, they cancel out. So the overall force is 0. Good? Okay, so therefore the acceleration is 0. Okay? F equals ma. When the force is 0, the acceleration is 0. No harm in writing F equals ma. Force is mass times acceleration. Okay? Right. Mention Newton's first law. So Newton 1, Newton's first law. When the forces on an object are balanced, so the overall, again, stress, overall force is 0, it keeps moving at constant velocity. Okay. And yeah, just finish off by saying this is called terminal velocity. Okay, so all that definitely will get you 3 marks. Okay, good. Right. The student has 5 steel balls of different diameter and some thick oil. Name 2 additional pieces of equipment a student would need in order to investigate terminal velocity, 2 marks. Okay, so we're into the tedious experimental bit. Okay, so 2 more pieces of equipment. Okay, so any 2 from, you need a transparent container. Okay, so what else? Yeah, a ruler, a balance to measure the mass or weight of the balls, a stopwatch, or if you've got it, a light gate, be even more accurate. Okay, that's enough. It's only 2 marks. Right. Describe a method the student could use to investigate how the diameter of a steel ball affects terminal velocity. Right. So, first thing, diagram. Get a diagram down. So let's have our container there with the oil. Got to be labelled oil. You need a meter rule or ruler next to it, which will be, so label it ruler, which will be held by some kind of a clamp stand. Okay. Point out your stopwatch. Okay. Anything else? Those are the main things. Okay, so start with the diagram. Next, write the method. Say what you're going to do. So, again, I won't write it out in full. I'll write it shorthand. So, for each size of ball, you should measure the diameter. Oh, micrometer. Yeah, you could add a micrometer to that list. So measure diameter with the micrometer. Okay. So it's asking about how the terminal velocity changes with diameter. Right, now, when you let go, so you have to hold the ball in the oil and then let go, okay? It doesn't instantly reach terminal velocity. It accelerates until the drag becomes large enough to become equal to the magnitude of the weight, as like we talked about, and then it hits terminal velocity. So, to show the examiner you really know what you're talking about, just mention this briefly. So say something like, you'd hold the ball just underneath the level of the oil. You wouldn't drop it in so it splashes. That's sloppy experimental technique. And just say, okay, so hold ball just under surface. Of the oil, okay? And then you want to say something about allow to reach terminal velocity. So you would start measuring, you'd start the stopwatch, not immediately you let go, but give it a little distance to achieve terminal velocity, which it will do fairly quickly in oil, and start the stopwatch when the ball passes that point, okay, that you've marked on the container. So start as it passes marked point. Okay? And then stop when it hits the bottom. Okay? Good. So, where are we? Yep. Now, the classic. Again, for each size, you have to repeat 3 times and average. Okay, very important. Always get that in. Right, so now you have an average time of the 3 experiments for each size of ball. So you can use speed equals distance over time to work out the speed. Now I know I keep banging on about the difference in speed and velocity. Speed is just speed, but velocity is speed and direction. So it's traveling in a straight line, so you're really calculating velocity here, okay? So you've calculated the terminal velocity for each different size at this point, and then you can finish by plotting a graph. Okay, now the thing that we're changing, the independent variable, is the diameter. Okay, so that would go on the x-axis, independent variable on the x-axis. And the dependent variable, the thing we're measuring, well, we're measuring the time, but we're converting it into terminal velocity. So you plot velocity. Okay, terminal velocity. Good. Okay, and then you'd get a bunch of points, something like this. Would it go through the origin? I'm not sure, maybe it would. You don't need to know whether it would or not to get the marks in this question. You just need to say that you would plot a graph of terminal velocity against diameter. Okay? Good. And that's it. That will get you your 5 marks. So always get a diagram in, discuss the method next in a sensible order. Always say repeat 3 times an average, okay? And always plot a graph. Good. Okay. Right. Final question, mercifully. Explain which type of graph a student should use to display his results. Okay. 2 marks. You've measured the diameter of different sizes of balls, okay? And you've dropped each one of these balls through this oil. So in a sense, you have discrete data. So it could be argued you could use a bar chart, right? You know, with boxes like so. And you can talk about this in your discussion if you've got time. Okay, it's only 2 marks. However, you're trying to show how the terminal velocity varies with diameter, and you know, a box plot, it's not great for that. You really want a line chart. Okay, so a line graph. So in another sense, though, it isn't continuous data because you could choose a ball of any diameter. You could have a ball that big or that big. So in another sense, it's continuous data. And again, if you've got time, you can talk about this. Okay, to get the 2 marks, if you're short of time, just say, I would choose a line graph because I want to show how the velocity varies with diameter, okay? And that's the best way to do it. Good. Okay, we got through it. I can't stand experimental questions. They're stressful. But there we go. It's over. And I hope it helped. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.